Good morning, guys. We are going to look at common inverter problem and solution. Basically, all the major problem common with all inverters and common errors display will fall under one or more of the heading listed below. So let us look at basic content of these articles. Then from there we'll understand what is the problem that common problem that inverter have, and then we'll find a solution to it. Inverter not charging. Inverter not charging. One, no power supply, bad input voltage or frequency, blown fuse, trip breaker, wrong connection, inverter fault or board issue, or battery full. These are the inverter not charging. If your inverter is not charging, these are the common problem. Then battery problem. Battery problem is battery under charge or overcharge. Battery charges or discharges fast. Battery voltage is too low. Reverse battery polarity. When we say reverse polarity, that means is that you take a negative to positive, then you take positive to negative. We are not talking of connection in series or parallel. This one you just connected directly to one battery. Let's say we have a 12-volt battery. It has a positive and negative, and the inverter is 12 volts. So let's say the inverter has a positive and negative. Instead of you to connect positive, positive, negative, negative, you interchange the polarity. That's what we call reverse polarity. Then we have corroded battery terminal. When we say corroded battery terminal, is the situation whereby you connect your battery, you didn't grease it to the extent sometimes, more especially this battery corrosion, it happened during when all these tubular batteries are not well properly maintained, whereby you will see a battery that is supposed to be well gelled, but they doesn't put the gel, so it's going to be corroded. Then swollen or battery, hot battery. What causes hot battery? It's overcharging. It's overcharging. And when you are overcharging your battery, you are weakening the cell. And by the time when your cell weak, what next? It's going to cut. And when the cell cut, your battery is going to be having a short circuit. So no matter any charging that you charge the battery, it cannot go up to 100%. And if your battery doesn't go 100%, what is the next? The number of hours of duration of the time will reduces. So why? Because the battery cell have been condemned. Yeah, so we have to look for those things. And when if we want to avoid battery overcharging, is a whereby we use the correct charging function. Correct charging function. When battery fully charged, it can cut. Then we have loose battery terminal. These are the common mistakes that installers today are having an issue on it. You will find out that an installer, let's say we are installing a 48-volt system, whereby you are connecting the in series, whereby you are connecting 4 battery in series. That is 12 times 4 is 48. So in this situation, okay, you are connecting 48 volts, and in the situation between the terminal, because you are rushing to finish the job at a particular time when the client have been given to you, then from there you started having an interference, moving faster, because you wanted to finish your job at a particular time, because you wanted to please your customers. And later on, when they didn't develop a problem, the customer would not know that you didn't touch this one, you didn't do this one, you didn't make this one properly. It's you as an engineer, as a technician, to observe what protocol is supposed to be duly observed. Let's go to number 3. Number 3 is inverter overload. What causes inverter overload? What are the common problems? Let's check out that we can do. Loading inverter above the rated capacity. Loading the inverter at the rated capacity. At the rated capacity. Let's say I have a 1000 kV. I have a 1000 watts inverter. 1000 inverter, 1000 watts is supposed to carry, and we have a tolerance. When we say 1000 watts inverter, you are not going to load it up to 1000. Load it up to 800 watts or 700 watts. Give a tolerance, because you don't know what the client will brought at your back. So what you are going to do is just load 700 watts. And some people at the end of it, they are going to load 2000 watts only, to 1000 watts. It's just like somebody that was meant to carry 20 kg, you times the 20 kg into 2, that is 40 kg. That is 40 kg, which is totally not supposed to be. Please, let's take note of this. Then we have short circuit condition. Short circuit condition is a problem. It's a common problem again. Then inverter faults. What's inverter faults? It's an error whereby it sometimes causes from the manufacturers. That is factory errors. We call them factory errors, because as the production continues, as the demand of production continues, and demand faster, the production moves. So definitely we will have an error in some places. So we need to check all those things. Then number 4, wrong circuit wiring and cable sizing. I want to talk about this cable sizing. I like to talk about this cable sizing. Cable sizing, every system to be installed it, there must be a rated cable that's supposed to be input and output. Like for instance, now you are installing a 30 kVA inverter using 4 mm. What do you think? What do you think? What do you think? Voltage, you must experience a voltage drop across the line. More especially, okay, you are installing 30 kVA inverter and you are using 16 mm as your battery cable. What do you expect? By the time when this battery cable started generating heat, you started losing current along the line. And when you are losing current, what happened? You are having a system collapse. So definitely battery cable rating is a very, 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 very something that we need to check on it. Then wiring. There was a house that I went in. They called me just to come and just to find out what is the problem, because the installer was not able to finish the job. I found out that the inverter, the output of the inverter is recycling, coming back to the inverter, feeding back the inverter. To the extent is cutting down the fuse. Inverter cut down, the fuse cut down. The inverter was trying to protect himself, because he supplies something and that thing still come back to him. It's just like you are moving out your energy strain and the energy is still coming back, recycling. So this is what happened. Please, when we are doing a load separation, let us do it in a proper solution. Sometimes I do used to advise, if you are doing such kind of thing, why can't you produce produce external DB? Produce an external DB in the house. By the time when you're producing external DB in the house, you will come and understand that, yeah, your proper isolation will be proper. If the house are using 3-phase, you use 1-phase as an inverter site. That 1-phase, you take it to the next external DB that you produce. That is all. These are the common things that we need to. Number 5, inverter display utility failure. Yeah. When you say utility failure, what would I mean? Battery not charging. Battery will not charge and will not supply to inside the inverter. When we say battery, when we say inverter display utility failure, that means the input is not coming from the NEPA or generator. The input is not coming, so power is not entering. Inverter overheating and harming. Overheating mostly is a cooling system, whereby you find out the inverter has a fan and the fan, unfortunately, something came along the line, or the inverter is not. One thing, mostly the reason why fan cooling fan inside the inverter die is because of the weather, the environment they installed that system to. Because at any time when the system sense that there is a heat, that fan will continue rotating. What do you think that if that fan continue rotating without stopping, it's weakening the coil, by the whereby the fan itself to some level is going to burn, or to skip, to stop working. And when that thing stop working, the circuit, they are having electromagnetic compatibility. So by the time they will start generating heat, before you know, 1 to 3 weaker components are going to start dying. More especially MOSFET circuit inverters. Sometimes IGBT try to return. IGBT inverters try to return. So please, let's try to understand it. Then we have inverter on bypass mode. If you see an inverter is on bypass mode, that means definitely it's not inverting. The inverter is not inverting DC to AC. So mostly in this time, we always first check our MOSFETs or IGBTs. We first check them. If they are okay, then we started checking all those ICs, all the regulator, oscilloscope IC, regulator ICs, all those things. Yes, then our diodes, we check them. These are the basic things that we need to check them. Then inverter shut down when power supply goes off. That means it's not inverting totally. It's not inverting totally. That inverter is not supplying, it's not inverting totally. So we need to understand it. Inverter return power to the inputs. You see what I'm talking before? It circulated, it move out, come in. In this section, the inverter will try to protect itself if it has a protection. But all these power inverters, they don't have that. As power return, it blown off. That's all. It blown off. Please, in a proper load shedding, let's try to separate proper loads to inverters. The inverter is choking. Yeah, when we say inverter is choking, definitely there must be a partial contact or short circuit in the system. So the inverter needs to be taken to the technician, or being an engineer, you were able to understand what is the main necessary test to work on it. Mostly, if you see inverter is shocking person, mostly it's a proper 80. Another thing is proper 80. If you add 8 inverter properly, it's not gonna shock you. Okay, like battery. Anytime when you are generating 30 battery, that's 360 volts. Even the frame himself is going to shock you. It's going to continue shocking until you properly check it. So you need a proper 80 in this system. Thank you. Let's meet in the next lectures. Thank you. I'm Engineer Rabo, CEO Rabo Multi Technology. Thank you for having me. Have a great day. Let's meet in the next episode. Don't forget to subscribe. Hit the button, subscribe, so that you'll be the first person to receive my videos. Don't forget to share, comment. Any place that I didn't make it wider, you can comment on the section box so that I can make the world wider, enlightening you. Thank you.